is Opubo. For those of you new to the channel, welcome. And for those returning, I bid you welcome back. Good to have you return. You are well appreciated. As always, in this channel, I present various ideas and designs of technologies, mostly from the Technology IP Bank of Enhanced Knowledge LLC, often integrated from several other technologies and made ready for adoption by the Adoption Brokerage Division. This presentation focuses on conservation economy, solar thermal Thermo-Transducer electric power, which focuses on the foundational need for enabling a conservation economy from the technological perspective, and of course also on the approaches for adoption of the technology by citizens of a geographical space, be it a community or region or even a nation, to simultaneously enable and ensure the sustaining of a conservation economy. Of course, what is essential is defined consequent on the prevailing civilization and the underpinning science. After all, as civilizations change, the underpinning sciences also change, although very often built on the sciences of the preceding civilizations. Besides, the term energy may very well be termed by different words in different civilizations. So the word is used here in concept of the underpinning science of the current civilization. Digressing for a moment, though, before making a deep dive into the energy technology, if you have not as yet subscribed to the channel by simply clicking on the subscribe button below, I implore you to please do so. Click the subscribe button now. The subscription would cause the system to keep you informed by notification of the next presentation the moment one is published, and also of course help me to more consistently continue to imbue the peace dividend of conservation economy. Now back to the presentation. By the prevailing civilization, and also as supported by the existence lifestyle since the days of the caveman, almost all devices operate on energy, and so quite correctly, energy is an essential need for conservation economy, as has been true for all preceding economies. The manner of availing society of energy has been a major issue of contention lately and has been an underlying factor in numerous conflicts. One of the damning aspects of energy production is the need for energy consumption to produce energy. So, a calculation of energy density and other sorts to validate the circumstances of net energy production is required. One such resource having been established to meet this criterion is fossil fuel, and it has been the mainstay of the energy industry. Yet, the utilization of fossil fuel has been argued by some humans as damning to life itself and should be discontinued. There has obtained as consequence this fossil fuel and green energy divide with so much rancor between nations and peoples. The arguments are varied and need not be repeated here, as there are volumes written on the subject that are out there for the interested reader. The capturing of natural resources of energies and extracting some energy in replacement of fossil fuel based on the civilization's underpinning science have been attempted in varied ways, but have run into one problem or another, with most of the issues being on the cost of adoption of the technologies. The cost, however, has not always been measured in pecuniary terms. Some were space needs versus human habitation needs, others were raw material needs versus human existence needs, and so on. So simplistic and low cost yet efficacious designs are warranted for compromise. The most tested design have been the capture of solar energy. In effect, all the designs have been a form of transducer, irrespective of the size or complexity of the technology. Naturally, therefore, a design that takes off of the solar energy enhancing approach would be more aligned with the objects of enabling a conservation economy, because there is sunlight everywhere at some time of the year. Hence, the designs can be reproduced in just about every region of the world. One such design in the Technology IP Bank that has obtained from the technology integration efforts is the technology of this presentation, solar energy thermo-transducer electric power, and it's as shown in the image. By concept, the technology captures solar energy of both radiant heat and photoenergy and converts both into thermal energy, which then gets converted yet again into electricity. By design, the technology consists of a solar boiler, which is what you see here at the leftmost end of the image, the picture you see right here. It is the process equipment. A flash equilibrium distillation, which looks like a bottle with a neck, up elevator, if you would pay attention. The second, the steam compression superheater, which looks like a drum on its side, right next to the flash distillation column. And then you have the Thermo-Transducer, which is box-like with a pipe-like bundle, but actually a bundle of wires extended out on one surface. And a DC-AC converter, and of course a controller system, both of which are not shown, having been extensively addressed in previous videos, and the links to the videos are noted in the pinned remarks. The key technologies of this particular technology presentation and is of the technology bank are the solar boiler, the process equipment that is leftmost right here, and the Thermo-Transducer, which is the box-like equipment all the way to the back, to the rightmost side, and the controller system. During operation, the technology captures solar energy, shown to the top as 3 arrows in depiction of the rays of sunlight with the solar boiler, that then heats water in convection through the boiler, such that by the outlet the water is virtually superheated due to the applied hydrostatic pressure, and is then statically flashed into the flash equilibrium distillation unit, producing saturated steam and boiling temperature water. The hot water is returned to the solar boiler, while the saturated steam is piped into the compression superheater, where the superheating produces superheated steam, and yet again some saturated steam and some water. The superheated steam is then piped into the thermoelectric transducer, which generates electricity by degrading the energy content of the steam. The transducer effluent is premixed with the inlet feed into the solar boiler, being bubbled into the pre-boiled hot water, where the bubbles ultimately collapse with some implosion and become water, yet again heating up the water in recovery of the energy, thereby preheating the pre-boiled water even as being heated in the solar boiler. Obviously, there seems a uniform acceptance that at this time there is in fact the energy technology upon which a conservation economy can be developed and evolve for the greater benefit. Provisions electric energy for use in every other technology of the conservation economy requiring energy. The materials of construction being mainly steel and having cylindrical forms, the technology is well suited to be fabricated out of used process equipment discarded by previous process industry companies, such as in many regions or readily transported to target region. Hence, the technology enables the utilization of discarded metal parts in every region, allowing for the elimination of matter that would otherwise be branded waste. So under the requirements of conservation economy, this technology holds its own weight. Now then, if interested in licensing this technology, please send an email to me. The email address is put in the pinned link below. Regarding licensing considerations, there are some notes of interest though. First, the technology actually licensed out is more complex than as presented here, because the actual technology usually, as its characteristic of process technologies, often involve the deployment of flow devices, measurement instruments, controller system devices, and what have you, making it a lot more complex than a simple depiction would show. The controller system is the same as the system deployed within the biotic resource electric power technology. The design of the controllers are deliberately made generic, and as such, all the customizations are implemented with just a change of a set of software, and so is the case with this technology. Further, although the solar boiler design is left non-specific, as was characteristic of earlier presentations, the equipment design is such that it can be replicated and several units operated together in a bank of equipment. Of course, the non-specificity of the internals of the design that provide the functionality is necessary by the European Union laws that requires IP being preserved so long as the design has not been disclosed at all. Besides, a solar boiler can be designed in myriad ways, spanning this low-end design all the way up to a very complex design, and as such provides options to every region of people. The Thermo-Transducer is particularly innovative, not in terms of design, but rather the fabrication of the component parts. In that sense, the technology is truly proprietary. I thank you for being here, and I appreciate your coming to listen, and hope and expect that you would consider coming back for the rest of the future technology presentations. The fact is, even if you do not care to adopt the technologies, some might just change their perspective of society and life. And until the next presentation, I wish you be well.